Hello friends, in this video I want to show you a script that we developed some time ago which came in incredibly handy during one of the largest projects we've ever worked on. To demonstrate the script, I'm going to bring in a digital train model in this project by going to the Browser tab, right-clicking on GeoPackage and choosing New Connection. Then I'll navigate to the project files that are attached to the description of this video and double-click on the GeoPackage there. It's going to appear under GeoPackage, just expand it and then double-click on the digital train model to load it in the project. Now let's use one of the previous scripts that we generated for extracting a slope map from a digital train model. So I'm going to open up the Python console by pressing Ctrl Alt and P, and then we can click on Open Script. And I'm going to load a script called Slope Extraction with Legend. If you haven't watched this video or used this script before, I'm going to link it under the description of the video. With this script, we can extract a slope map and a legend for that slope map based on the slope ranges that are defined here. You can, of course, change these, change how many number of classes are extracted, as well as change the colors that are applied to the slope map, and you can also adjust the parameters for the legend. But I don't want to get into this right now, I just want to extract the slope map very quickly. All I have to do here is to just specify the export path for the slope and the legend. So I'm going to assign one that I have prepared for this video and click on Run Script. Now I can see the slope map was generated in the project, and also if I go to that path that I specified, we can see a legend was also automatically extracted there. What I want to achieve, and also something that we had to do a lot of in that project that I mentioned, is to extract a polygonal boundary of a specific slope range, so that those polygonal boundaries would later be used to classify a land for a given use. For example, on certain slopes we could use tractors, on other slopes we had to do hand planting and so on. So we had to do a lot of these boundary extractions and also calculate their area. So I made a small script that automates this entire process. Now if I expand the data band of this slope layer, we can see the ranges that have been defined here, and also these correspond to the ones that we defined in the script. Now let's focus just on a specific range that we may want to extract. Let's say 10 to 15 degrees, for example. I'm going to double click on the slope layer and switch this to single band gray. And then let's switch the contrast enhancement to clip to min max. And then for min, we're going to set 10, and for max 15. This is going to isolate that range for us. And then I'm going to press OK. I'm also going to turn off the DTM, and now we can see in the viewport just those slopes between 10 and 15 degrees. Now the only reason I did all of this is just so I can demonstrate what the new script is doing, but you don't actually have to go through this process. Now let's switch to our new script called Extract Range Boundaries, so I can explain the parameters. What this script is basically doing is targeting a layer within your QGIS project that has the name that you have specified here as an input under raster layer name. Once it finds that layer, it's going to target any value ranges that you have specified here, and it's going to extract those as separate polygons. You can specify as many value ranges as you want. Now in this case we are extracting value ranges from a slope map, but the script doesn't actually care what kind of raster it is specifically, as long as it has linear banding. So you can extract value ranges from slope maps, aspect maps, height maps, also from digital elevation models, or any other kind of raster like that. I am going to specify here that we want to extract the value ranges between 10 and 15 degrees of this slope map, but again, you can specify as many as you want. Under area in hectares, you can decide if the script should calculate for you the area of the new polygons in hectares, or if you want, it can be also in square meters. If this is set to false, then the calculation will be in square meters. If it's set to true, then it will be in hectares. Under Calculate Total, you can choose if you want the script to create a new attribute for you in the polygon layer, which is going to list the sum total area of all of the features in that layer. Under Unify, you can decide if you want the script to merge all of the features into one multi-part feature, or if you want all of the polygons within that layer to remain separate. Obviously, if you merge all of the single features into one multi-part feature through the Unify parameter, you don't actually need to calculate the total area, because it's going to give you the total area anyway, since you're going to have only one polygon on that layer. Under Simplify, you can control if you want some kind of simplification to be done to remove extra vertices from the resulting polygon layer. By default, this is set to 0 or off, but if your polygons are very complex, you can simplify them using this value. Likewise, with the gap fill value, if your polygons are generating a lot of these small gaps, which naturally they do if the underlying digital train model is of high resolution, then you can choose if you want to fill those up. Just be careful when you're using the gap fill because it creates a lot of extra vertices along the edges of the new polygons, so you may want to use it in conjunction with the simplify parameter. And beyond these parameters, you don't have to do anything. Just again, be careful that you specify the exact name of the layer that you want to target. I've already assigned the value ranges I want to extract, so I'm going to run the script like that. Now you can see a new polygon layer was created called range-10 to 15. So it's going to use the value ranges you specified and add them to the name of the layer so that you don't get confused if many polygon layers are generated if you have many value ranges. Let's see if this new layer matches exactly the underlying raster layer, which we can see it does. Also, let's open the attribute table for it, and we can see now the parameters here. We have one for the minimum value, the maximum value, also the area. This is currently set to hectares because we have set area in hectares to true, and the area total is also the same. Again, this is because we are running the unify parameter as well. If we turn this off and set it to false and then run the script again, we would now expect to see all of the individual polygons within this layer, and they also have their own area calculated, but we also get the total area if we are running the total area parameter set to true. Let's increase the simplify parameter here maybe to 2 just for visual demonstration. I'm going to run the script again, and now we can see the resulting polygons have more straight segments and a lot less points. Now I want to see if I can extract all of the value ranges that were specified in our original slope map. So I'm just going to copy and paste those here. And now we can run the script again. I'm just going to make sure that I don't have the simplify and gap fill parameters turned on so I can speed up the process. And there we have it. All of these slope ranges were extracted. We don't actually need these original 3 layers, so I'm going to remove them. And now our slope map looks like a nice mosaic. And so with that done, thank you for watching. I hope that you find some use for this script in your day-to-day work. And if you do find it useful and you like this kind of content, then please like, share, subscribe, and comment so we can grow the channel and make more content. Thanks again for watching, and we'll see you in the next video.